Folks, so we've got a quick overview of contour lines and their basic mechanics. Now let's look at what that looks like in the real world. So here we're using ArcGIS, which is Geographic Information Survey, and I've pulled data from the Data WA database, which is free. It has most things for free. You have to pay for some, and some are restricted access, but the contour lines we're using today are for free. We're going to zoom right into Stirling Range National Park, which is a mountain belt down towards Albany. If you zoom in enough, the contour lines will start popping up. We're going to go over to the west side out towards Mount Toolburn up here. When it loads, there we go. So we've got Mount Toolburn up here, and this gives us a really good example of some really definitive features that we just talked about before in the real world. So we'll look at it eyes down, and then we'll try and look at it from a 3D perspective. So, like we talked about before, we've got the spur lines here coming off the side. And we can tell these because they're these very long, slender finger-looking things. And on over here, between 550 and 620, it looks like a nice flat spot where we could camp. We can see how the contour lines are really crammed together on the sides. And that's how we can tell that it's particularly steep. So down here, where it's about 400 meters above sea level, and up here it's 760, that's roughly about 200 meters. So between 200 meters, it's lost 360 meters. So for your expedition, you'll have to do the calculations on this and work out the gradient, because again, the gradient would be the height lost over the distance. So it'll be distance on the bottom axis, height on the top axis, and distance lost would be how you'd work it out. So between 400 and 760, you're losing a very steep gradient compared to when the contour lines are further apart, which would be much more flat gradient out like that. Moving around, if we zoom in a little bit, we can see the knolls here at the top. We're at 760 meters, and we can see a little saddle in between. This saddle's not that significant because there's only 10 meters difference between the two. However, if we zoom down to here, this is quite a significant saddle. So between this point here, looks like a little man or the X. My paintbrush. This point here, we've got a big gradient on both sides, but also it's got a gradient dropping down either side of it as well. So there'd be quite a significant stream in here because this is a gully where all the water will be flowing off the mountain, both sides, off the saddle, down through that gully. So it probably wouldn't be a particularly nice place to hang out. It'd be quite swampy, quite wet, quite overgrown through there. If we look over here, this is quite a significant spur line. This really long finger line that comes up to the top, and we've got a knoll up here. As you can see, it's quite steep, quite symmetrically steep all the way around, except for the side with a big long spur. So if we were to plan to get to the top of the mountain, I would ask you guys which way would we go, and I'd ask you to justify your reasoning as well. So as you can see, I just tapped a contour line and it turned blue, and that tells me that that's one complete contour line. So if I stayed on that contour line and then go up and down, it's called contouring, and I just stay around that level of the mountain, like so. Cool. We'll pause there, and then we'll get into the 3D modeling of contour lines and what they look like, and then we'll go over to you guys onto your activity. As we can see here, we've just gone into the three-dimensional mode, and we just had to go into landscape to alter that. So as we can look around this mountain, we can see significant features. We can see this big spur line over here coming off the sides, and we can see how it's significantly steeper coming off either side of the mountain there. If we go over to this mountain here, we can see how there's quite a really defined long spur line coming up the west of that mountain, and then it drops off around each side of the mountain. So the question for you guys is, why are contour lines important? what do they tell us, and how are they useful in the field.